S S Rajan, Professor of Marine Engineering. Today we'll be talking about the gas turbine, the basics of gas turbines. It is focuses only for the students at a very basic level. Thank you very much. Now, what's a gas turbine? Is a rotary equipment. The, the difference between the gas turbine and reciprocating steam engine, reciprocating IC engine is that both are internal combustion engines. But one thing is that the reciprocating engine, there is a conversion, a floating link like connecting rod is required to convert the real linear motion into rotary motion of the crankshaft. But this is not required for the gas turbine. One of the drawbacks of gas turbine is that we cannot run the gas turbine as a very, very low RPM like diesel engine, IC engine, slow speed engine, which can be run at 90 RPM. But as far as gas turbine is concerned, we are talking about the RPM to the level of 14,000 RPM to 32,000 RPM, that is revolution per minute. So that is the basic difference between the gas turbine and the internal combustion reciprocating engine. Now, as the speed gets lower down, the lubrication will become more difficulty because the lubrication regime will tend to focus towards the boundary lubrication. So therefore, we have to be very careful in order to achieve the hydrodynamic lubrication. The shaft has to rotate a minimum at least 100 RPM so that the crankshaft or the shafting system will float and there won't be any metal-to-metal contact between the bearing and the running shaft. So that is achieved only at minimum 90 to 100 RPM. Whereas this probably is not there for the gas turbine lubrication. It's very easy. In fact, the modern gas turbine, which is a smaller in capacity, in modular form, they revolve at the RPM of 35 to 40, 50,000 RPM. In fact, the lubrication is purely air, done by air. What we call aerofoil section. We have aerofoil section in a foil form, which is going to lubricate the turbine shaft, and is only depending only on the viscosity property of the air. That's all. So virtually the gas turbine shaft is floating, and there's no metal-to-metal contact. So this is, but the amount of power output is limited. So that's the reason why it is utilized in the form of a modular form. That's very compact form, which is portable. Wherever you require portable power, you can use this modular form gas turbine. Wherever gas is available in free quantity, you can utilize this modular form gas turbine for power generation. Very similar to what you have in the shore-based shops. You have a generator. Same way, you can have a gas turbine generator, provided you have a free supply of methane gas to run the gas turbine. Okay. Now, the gas turbine actually originated in the year 1955. That time, the temperature was limited to 650 degrees centigrade, and the maximum pressure that was achievable on the gas turbine inlet condition is 6 bar, and power output was about 0.3 kilogram per kilowatt hour. Okay, and this was a twin unit. And one of the important point that we noted about the gas turbine is that the gas turbine cannot be started automatically. It is not self-starting. It doesn't have self-starting property. It has to be started by running the turbine shaft by means of using an electrical motor through a gearing arrangement. Once the RPM is picked up for the gas turbine, automatically the combustion will take place and it will sustain the revolution, and we can disconnect the electric motor. Otherwise, we can use sometimes the older version, they used to spin the propeller blade to start the gas turbine. That is not required. Nowadays, we have an electric motor to start the gas turbine. Electrically, we can start it, which is coupled to the gas turbine shaft through a gearing arrangement. Okay. And second thing is that Because we're talking about very high temperature of the gas turbine, we are talking about 650 to 800 degrees centigrade. So the limitation of gas turbine is the power to weight ratio is, even though it is very less, but the material components has to sustain this, the thermal stress, that what we call in technical term a thermal creep at such a high temperature. The material should be substantially or very strong, resistive to high temperature. So the common material that we use is the titanium because of its very lightweight. At the same time, it is having a very high strength, even though weight is less as compared to nickel or aluminum based alloy. So the common material is the nickel pneumonic alloy or molybdenum alloy or with the cobalt mixture, and having a combination of titanium as a parent material. So that is the gas turbine construction as the construction is concerned. The main component of the gas turbine is it has got a common shaft. You have a compressor wheel, multi-stage compressor wheel attached to the a gas turbine, which is also multi-stage. It has got LP stage and intermediate pressure stage and HP stage. And on the compressor side, again, you have the first stage, second stage, and the final stage of compression. Maximum compression pressure ratio is at 6:1, That is what we achieve for a gas turbine. That is sufficient, but gas turbine, even though pressure is low, it produces a large quantity of large volume of gas, where gas is generated in a combustion chamber. So there are different kinds of combustion chamber. One is called the can combustion chamber. Other one is called this is the thermodynamic cycle on which the gas turbine is working. That is called the Brayton cycle. The compression, 1 to 2 is compression, 2 to 3 is combustion, 3 to 4 expansion through a turbine and exhaust nozzle. Okay, this open cycle, there is not a closed cycle, unlike an IC engine, reciprocating engine. It is a open cycle. Okay, the thermal efficiency depends on as high temperature the turbine, combustion chamber, exhaust. Inductive turbine should have very high temperature, tending more towards the Carnot cycle, where highest temperature minus lowest temperature divided by the highest temperature, that is the Carnot efficiency, and your adiabatic compression, adiabatic cycle of this turbine cycle processes is tending towards Carnot cycle because of very, very high temperature. So that is one aspect of the turbine, gas turbine. And gas turbine is quite different from a steam turbine. The steam turbine uses the steam for propulsion, whereas gas turbine uses the gas for propulsion. One of the important differences is that a gas turbine can work efficiently only at about 80% of the thermal load, 80% of the mechanical load to which it is connected. Below 80%, the gas turbine is very, very poor in efficiency. So it has to combine with the steam turbine to have a combined heat cycle, combination steam turbine and gas turbine. For that, the steam turbine will take care of from no load to 80% load, and after that, the gas turbine will take over to cater for the peak load in a thermal power plant. So thank you. This is what my brief introduction of the gas turbine. I have not be going into much theory. Only you can say all the series are done in the lower class level. Mostly it is about the Charles law and the Boyle's law and the gas law, that is universal gas law, that is PV is equal to nRT, that is the common formula that is utilized for arriving at the thermal efficiency for a gas turbine. So this can be worked out in the school level or elementary level. We can achieve what is the correct formula for the gas turbine thermal efficiency. Thank you very much for the gas turbine interaction. This is sufficient for this at this level. Okay, mostly the application is for aircraft industry. Land-based installation, we have only where the methane gas is available in plenty. There you will find. For India, you will have gas turbine plant mostly in the Karaikodi region of Pondicherry domain. Okay. We have gas turbine plant, but otherwise the gas turbine is not very abundantly found in the India. Okay. Thank you very much.